Okay, so welcome. Welcome, Claudia and Morgan and Stephanie and Sean and Lizbeth. This is the week 3 webinar. A little different than last one. Last one we kind of doubled up because we had the project also. This should be more of a regular one. We're going to be doing, it sounds really long because we're going to be doing chapters 4 and 5. But I want to let you know we don't do all of chapter 4 and we don't do all of chapters 5. So that is important. You're welcome to read it, but you won't be testing all of them. So you're only going to be tested on the first few sections of each. So in particular, if you look at the sections on chapter 4 and 5, let me just pull it up on my other screen. You will see in chapter 4, we are going to be doing 4.1, 4.2, and that's all. So you can ignore 4.3, 4.4, 4.5, 4.6. Actually, we do 4.3, sorry, 4.1, 2, and 3. You can ignore 4, 5, 6, and 7, and 8. So we're only doing a piece of these chapters. Again, you're always welcome to read it, but you won't get tested on it. And chapter 5, we'll do chapters 5.1 and 5.2, and you don't have to worry about 5.3 or 4. So that's just a note, is that we do like half of each chapter. And that's kind of standard statewide. I always, when I go to conferences, I check to see what everyone else is doing and try to keep it standard. I don't want to torture you more than you need to be tortured, but I do need to cover what everyone else in the state covers. So I'm pretty active in the state to make sure that it's transfers. That's, again, number one is this transfers. So what I'm doing for you guys, there'll be no question about it when you get to your university, especially Cal State or UC, because that's an automatic transfer. If you go to somewhere in Florida, I have no idea. But at least if you go to one of the ones here, or if you go to UNR, University of Nevada, Reno is also very close to us, so we make sure transfers there. So that's just a note, is that we don't do all of these 2 chapters, but we do some. And in particular, what we're going to be looking at is two different types of data. And we saw in chapter 1 the name of the type, so we didn't do anything with it. So do you remember, if anybody remembers, and I'll let you put it in your chat box, see if you remember, the difference between a discrete distribution and a continuous distribution. So discrete variable versus continuous variable. See if any of you remember, you can say it or put it in your chat box, either way. Hey, Chris, thanks for showing up. And if you remember, discrete versus continuous. Again, that was a chapter 1 idea, but chapter 4 is about discrete and chapter 5 is about continuous. Nobody recalls? Here we go. Yeah, discrete distribution you can count, continuous you measure. So discrete is a random variable and is finite, typically finite. Continuous is not discrete. Okay? So finite, or at least what's called countable. So you could list it with ... Okay, another way I like to look at it is a little grammar. If the question is how many, then that tends to be discrete. So for example, how many pets do you have? That's definitely discrete, right? You can have 0, 1, 2, 3, 4, all those whole number type things. But how much time did you spend on the last section, the last chapter that you worked on the homework? Notice that's a how much, and that could be any real number in between. Does that make sense? Not just the whole numbers. You could have spent, 3.125 hours, for example. Does that make sense? Okay, so that's a big difference between continuous and discrete. And it's very important that you know the difference because we have whole chapters on them, but we only do half of each chapter. So any questions so far? Any questions? So let me give you some examples that are kind of fun. If I take this little die right here and I roll it and I look at it, is that discrete or continuous, the outcome?
It's going to be discrete.
Yeah, that's discrete because there are only 6 sides of this die. Is that clear? Okay, so there are a lot of discrete things. What about if I look at my pens? I got a lot of them here. And I look to see how much they weigh. So I'm going to measure, I'm going to put on a scale, which I don't have here, but I can pretend like I do. And I look to see how much I weigh, I write it down, I go to the next pen, and I write it down, and I keep doing this all day long. Is that discrete or continuous? So is how much the pen weighs, is that a discrete or continuous variable?
Discrete.
Okay, good. I like the rest of your answers. Continuous, continuous. First thing, it's how much does it weigh? That's a how much is continuous. Second is it does make sense to have, say, 1.32 pounds. You could have decimals in between. Does that make sense? If I said, how many pens do I have in my hand? That's discrete. But how much do they weigh is continuous. That's a measured quantity instead of a counted quantity. Is that clear? Any questions on that? Okay, so that's a few things. I'm gonna spend most of the time now just working out problems. Again, right now I just wanted to give you the idea. So let's pull up some problems. So let me go grab, and I'm going to start with discrete, and then we'll get to continuous. So let us go ahead and share my screen. Go to my paint. Hopefully it works. Pop it in, paste it. Okay, so this is something I'm going to show you how to do. I don't expect you to know all the words in this unless you read the chapter and watch the other video. But write down the probability distribution table for the following. And the first one I've got, we'll see how much time we have, is a car salesperson gives out a $10 gift to every customer who test drives a car. So I know we had a couple people that were thinking about business majors. It's a typical business major question. 12% of all the customers who test drive the car purchase the base model of the car, resulting in a $200 commission for the salesperson. 8% of all customers who test drive a car purchases the deluxe model of the car, resulting in a $300 commission for the salesperson. Write down the probability distribution function for the salesperson's profit, find the expected value, standard deviation, and interpret. And then, is it a lucrative job? So can you all picture what's going on here? Very typical. You give a little gift out, and then you hope they buy what you're trying to sell, right? Okay, and different things could happen. Either you don't sell anything, you sell this kind of smaller thing, or you sell the biggie. Okay, sometimes there could be a lot of different types. First thing, is this discrete or continuous?
Continuous.
What everyone else says? Okay, so you're all over the board here. So it's discrete because there's only 3 different things that can happen. You see that? There's 3 things that could happen. Either the customer could not buy, and then you end up losing $10, right? Because you just gave them a gift and you didn't get anything out of it. Or the customer can buy and only buy the base model, and you gain $190 because you get $200, but you had to pay $10 for the gift, right? Or they could do the supercar, the deluxe car, and you end up with $290. $300 minus a $10 gift. So there's only 3 different choices. So that means I could list the choices. If I could list the choices, it's discrete. And because of that, I can draw a table. So let's do that. And I'm going to draw the table. So just to let you know, and you could draw it horizontally. Oops, didn't give me the, let's do it one more time. There we go. You could draw it horizontally or you could draw it vertically. I really don't care. So I'm going to do a little horizontal table. And we know there are two things. Well, there's the amount of profit that you get, and we call that X. Then there is the chance of getting that amount of profit, which we call P of X. Hopefully you all know what P stands for. What's P stand for?
Probability.
Yeah, probability. So we have the amount of money that the salesperson is profiting for X, and we have the probability that that salesperson is going to get that amount of money. So the different things that could happen is, let's be optimistic. The very best thing that could happen is how much? How much money? If you're the salesperson?
$300.
Yeah, but it's $290 because remember you got to spend $10 on the gift, right?
Right.
So it's $290. Chris saw that, which is good. So $290. You don't need to draw the dollar sign. What's the next best thing that could happen? What else could happen? Yeah, 190. And that would be just the regular old economy car. Is that it? Can anything else happen?
You lose $10.
Lose $10, and that's -10. And that is most likely to happen, actually, right? So don't forget about the thing that's the most likely outcome. That's I've noticed a lot of people forget about the most likely one on tests and stuff. Now, the probability is just given. Probability of ending up with a $290 profit is 8%. But turn it into decimals. Don't forget, probabilities are numbers between 0 and 1. You can't have numbers like 8. Is that clear? So instead, it's 0.08. The probability of profiting $190 is 12%, but we need decimals, so it's 0.12. What's the probability of profiting negative $10? Put in your chat box. Yeah, so it's 0.80, and that's the rule of complements. Because 0.8 plus 0.12 is 0.20. 1 minus that is 0.8. You always have to add up to 100%, right? So there's what's called the probability distribution table. Probability distribution tables always have 2 rows or 2 columns. You can choose vertical or horizontal, but they're labeled X and P of X, where X are the different possible outcomes you can get, and P of X are the probability of each of those outcomes. Any questions on that? Okay, so the next thing we need to do is we need to find out what the expected value and the standard deviation is. So there are formulas for this, which you don't need as long as you have a calculator. The wonderful people from Texas have developed this great calculator that does everything for us. And there is a formula, but I'm not going to go over that here. Instead, I'm going to show you how to use a calculator, because that's really important. So here's a calculator. I'm going to clear whatever was there. So what I'm going to do, and you're used to this, I'm going to get a stat. Hopefully you're used to this, because we've done this before. I'm going to go to Edit. Whatever I have in L1, I need to clear it out. So I go up to L1, clear, enter. I go up to L2, clear, enter. And L1 will be my X's. And remember, the X's were 290. Let me move the chat box so I can actually see the numbers. Yeah, 290. 190. So I basically put the table in the calculator. And then -10. Just to note, because a lot of people make this mistake, This one in between the plus and the times is not negative. So don't hit that button for negative 10. That's subtraction. This one below the 3, that's the negative. It's one thing that they didn't do so well in Texas is they made it a little bit confusing. So that's a mistake I see on the calculator, and people are like, what's going on? How come it's not giving me an answer? And that's it. You have to remember that for a negative value, you need that number under the 3. For subtraction, you need the number to the right of the 6. So now I can enter. And then L2, I put the probabilities. So we had 0.08. We had 0.12 and 0.8. Any questions so far? Okay, so now you got to remember what to do. We hit stat again. We hit calc. Then you hit enter on OneVer Stats. There's 2 kinds of calculators. There's this kind, and I'll show you how to do this kind. And that is you have your list, the L1. So if it's not in there already, you go second 1. And then freak list is L2. So second 2. If you have the other kind of calculator, it'll show OneVer Stats, and that's it. And then you type in second 1, you type in the comma, and then you type in second 2. The video that I have, the short videos and also long video, show the other kind of calculator. So I like to show you both, once for the webinar for this type, and then for the other type I show you for the other videos. I got to calculate and hit enter. Any questions so far? All right, the interesting thing is there's another word for expected value, and it's called mean. You've heard that word before, right? I'm not going to get involved in the details of why, but mathematically they're actually the same. So what we say is the expected value is 38. It's the x bar. The standard deviation is a sigma, and that's about 98. So let me write that down. Let me unshare. Unless there's any questions, I'm about to leave my calculator. We can ignore everything else, by the way. But we definitely have 38 and 98. And let's go back to the problem. So first thing, I want to do it in pencil, is that the expected value, use the mu for. Sometimes you use EV also. Then I can write 38. And then the standard deviation was 98. Any questions on that so far? Okay, so now it's time to interpret both the expected value and let's interpret the standard deviation, and let's decide whether this is a good job.
Can I ask a question real quick?
Sure.
Why is it 98.47? It's just 98.
Oh, it is 98.47. It's not exactly 98.47. It's 98.468269. I just rounded.
Okay.
Okay, but that's a good question. And what you should do when you're doing the computer exercises is whatever they tell you. Okay, me actually, whatever I told you. So if I say round to 4 decimal places, give 4 decimal places. If I say round to the nearest whole number, like this one, you round to the nearest whole number. Does that make sense? So I just rounded. You have to decide what to round. This seemed like a good number to round. Nearest dollar is what I rounded to. Okay, so now I'm going to interpret. So here's how you interpret. So for the expected value, there's some very specific words I want to see. So one is that if the salesperson has many customers, then it is likely that the average profit per customer will be close to $38. So I want to let you know of a few things. One is that there's some words you must have. So let me write down some words. I'm going to put them in red this time that are in there, and they're going to be in every one of these expected value kind of type of problems. One is many. Another is likely. Another is average. Finally, close to. Those words have to be in there. So if they're not in there, you will lose points. Okay, so if I give it on the exam, you have to have those words or you'll lose points on the written exams. Any questions at all on kind of how to interpret it? Okay, now let's look at the standard deviation. Okay, the standard deviation is 98. If you remember, the standard deviation tells you how spread out the data is. Does that make sense? So that means if you go down one standard deviation from 38, then you're going to be negative 60. You see that? 38 minus 98 is negative 60. You stick it in your calculator, trust me, either way. Now, that's bad, right? That means you just lost a whole lot of money. Okay? So what this says, so based on the standard deviation, let's write it not in red. Based on the standard deviation, the job is unstable. Some days, sometimes, or some days, the salesperson will make a lot of money. But other days, the salesperson will lose money. Any questions on that? So if you're the salesperson, you look at this job, is it a lucrative job? You guys know what the word lucrative means? What do you think? Is this a lucrative job? How long do you think it takes to work with a customer as a car salesperson? Which I've never been, but my brother was, actually, when he was in college. How long do you think it takes? Just a guess. This isn't a math question.
At least 2 hours.
You think it's 2 hours to work with one customer on a test drive? What do you think? You all agree? So I always get different answers when I ask this question. Okay, so if it takes 2 hours, okay, we'll go for the 2 hours. Then that means that on average, the car salesperson is making $19 an hour. Do you see that? 38 divided by 2 is 19. Okay, so for a starting job with no experience, that's not so bad, right? It's not great. You're not going to make millions, but it's an okay job. But the standard deviation's high, which means that there's stability issues. So you better have a lot of money in your bank because you can't rely on a paycheck each day. Some days you're actually going to lose money. But if you go long enough, then you're very likely to average about $19 an hour. Any questions on this idea? Okay, so just like always, I'm going to let you know you got 3 seconds to tell me you need to keep this up, or I'm going to erase it so I can get to the next problem. Going once, going twice. That's a little more than 3 seconds, but not too much more. And let's do another one. Okay, so now we're going to do one that's very different. Very different kind of problem. Okay. All right, I got this online, so it must be true. So 21.2% of high school seniors have used marijuana. So a study of 200 high school students in states that have legalized marijuana for recreational use found that 49 of them have used marijuana. It's supposed to be A and B, but it never copies and pastes right. So the question is it statistically significant? Okay, so I want to find the probability that at least 49 of 200 have tried it. Any questions on the question? I don't expect you to know how to do this, but do y'all know what it's asking? What's the probability that if you randomly pick 200 people, okay, that at least 49 will have tried it, marijuana? So what we want, let me write down what we want, because if you don't know what you want, it's really hard to find it, right? So we want the probability that X is at least 49. So I'm going to write greater than or equal to, in a weird way just because I'm typing, 49. Any questions on that? We know for any individual high school student, okay, it ought to be 21.2% or 0.212. I'm going to call that lowercase p equals 0.212. We have a sample size, which I'm going to call n, is equal to 200. Any questions so far? Okay, so this is a very special kind of survey. It happens a lot. First thing, the question is a yes-no question, right? Either you have tried marijuana or you have not tried marijuana. Do you agree? You can't kind of have tried marijuana. It's not, it's pure yes or no. But yes or no's happen lots of times in surveys. I'm sure you have taken surveys where you do yes or no questions, right? Okay.
Bill Clinton, then you could have only, you didn't inhale.
That's trying it though. I didn't say smoked. He tried it. He tried it. He may not have smoked it. Of course, I don't believe that, but he definitely tried it. Okay. Any questions so far? Okay, so if you have the situation where we have yes, no question, and you're doing a survey. So in this case, our survey is of sample size 200. And you want to find out probabilities involving how many people say yes. Then it's got a special name, and that's called binomial. So let me write that out. So binomial. This is important. And that means that we have yes, no question. Okay, and a sample. We want the probability of a certain number of yeses. And that certain number could be at least a certain number. It could be less than a certain number. It could be equal to a certain number. It could be less than or equal to a certain number. So we have all kinds of different choices there. Any questions so far? Okay, the good news is the first thing is our calculator can only handle less than or equal to. It cannot handle greater than or equal to. Okay? And notice this is important because you'll get the problems wrong on the test and on the homeworks or whatever the assignments. is the word at least. You see it says probability that at least 49. At least is not the same thing as less. At least means that number or bigger, right? So you have to be at least 21 to get into that bar. You've all heard that before, right? So a 40-year-old can go in. A 12-year-old cannot go in. What's that? Okay. So we got, somebody's got echo. So I'm going to mute you guys. And then you can unmute if you have questions. But I was getting some echoing, and that's not good. Okay, so what we know is in this case, this is a greater than or equal to, and we can't handle greater than or equal to. We need to turn this into a less than or equal to. So here's my suggestion. And just humor me and say, good idea, okay? What I'm going to do is I'm going to write down some numbers, just numbers for fun. Numbers near 49. I'm going to write 47, 48, 49, 50, 51. Okay? Maybe I should dots on both sides. And then greater than or equal to 49. I think you all know, I hope, that greater than or equal to 49 will be these guys. Is that clear to everybody? Any questions on that? And again, if you have a question, just unmute yourself, but we're getting echoing, so I had to mute you. Okay. Oh. I just realized the chat is not showing. There we go. Okay, so we need it to be a less than or equal to, and the way you handle that is the rule of complements. So let me write down a little equation. We can say that the probability that x is greater than or equal to 49 is equal to 1 minus what's not circled. And what's not circled is 48 and below. So let me know if that's confusing. So probability that x is less than or equal to 48. Any questions so far? Now I can go to my calculator. Let's jump into the calculator. And let's just clear what we had. So here's what I do. I'm going to go to stat. Okay. And what we want, I'm sorry, not stat. We're going to go to, so if you want to find out a probability, we're going to go math, I believe. It's been a little while since I did this. And then we're going to go to prob. Okay. Sorry, distribution is what I want. And then you can go up arrow if you want, or down arrow. Up might be a little easier. We're going to do binom CDF. So you do CDF for less than or equal to. You do PDF for equal. I hit enter. This kind of calculator, it asks you number of trials. And this kind, the number of trials here was 200. We have our P was 0.212. We have our X value, and that is, remember, we want to find out probability less than or equal to 48. So 48. I could paste. And just enter. So it's about 85% chance, or 0.854 if you want. Again, it depends how many decimals. I'm going to go 0.85. So we want 1 minus that. So let's go ahead and pop it in there. Equals 1 minus 0.85 about. and that is equal to 0.15. Any questions so far? Binom CDF versus PDF. Okay, so if the question is what's the probability that it was exactly 48 people that said yes, then you'd use binom PDF, and it would look very similar. But this is the probability of a less than or equal to, and that's CDF. So Chris, does that make sense?
Yes, it does.
Yeah, so it's all about equal versus less than or equal to. If it's greater than or equal to, we have to do this little rule of complements thing. If it's less than, you need to turn it into a less than or equal to. So for example, less than 10 is the same as less than or equal to 9. Okay?
Hey, Larry,
Yeah.
Larry, does the CDF, does the C, D, and F, does that stand for anything?
Of course it does. I wasn't getting into the technical details, but CDF stands for cumulative distribution function, and PDF stands for probability distribution function.
So how do you know which order to put the numbers in?
Right. So if you have the other kind of calculator, the easiest way to remembering it is it's alphabetical. NPX.
NPX.
Yeah. Yeah.
Thank
So if it's the kind of calculator where it just gives you binom CDF and doesn't have the menus, then it's just alphabetical, which is convenient. And then you got to put a comma in between. That's N, P, X.
Gotcha. Thank you.
Yeah. Okay. Any questions on this so far? Any more questions? These are good questions, though. Remember, the whole point of these webinars is to be able to get instant questions answered. Okay. Would your answer change if you found out later that some students lied? Now, these are high school students. Do you think they're going to tell you if they smoked marijuana before? Some might not. And actually 54 of them had smoked marijuana. Just a note. Let me write this down too because it's important. I think I've done this before, but now we're getting it again. Statistically significant means less than 5% chance. Okay, at least for today. So notice it's not statistically significant because we got 15%, not 5%. Okay, for part B, what if it was 54 instead? Okay, actually 54. So again, if you circled it, I'm not going to go through the whole thing, but greater than or equal to 54 is the same as less than or equal to 53. So if I go to my calculator again, and let's go to share, calculator, it's almost there. And I go back to second distribution, binom PDF, and oh, it doesn't keep the old stuff, but that's okay. 200. P-value is 0.212. The X value was now 53. Paste and hit enter. And now we'll see it's about 1% chance, maybe 1.3% chance. And that's actually less than 5%, so that we say yes, it's statistically significant because we have a very small chance of it happening. Any questions on this idea? Okay, so now I'm going to go to the next chapter. Oh, did I run PDF? Oh, I did. Sorry about that. That's important. It's going to be probably almost the same answer, though. Second, I was trying to go fast because I want to get to the next chapter. That's what happens when I go fast, is I click the wrong button. Or I click enter too many times is what I did. So one more time. 200. And p-value, the probability was what was it? 212. The X value again was 53. And we get 0.97, subtract from 100%, and you get 3%. Still statistically significant. Any questions on that? Okay, so now I want to talk about continuous distributions. So let's go to Paint. So first thing, when you have a continuous distribution, I'm going to erase all this, by the way. When you have a continuous distribution, you can't have a probability distribution table like we did because you can't list them all. Remember, continuous has an uncountably infinite number of possibilities. You can't list them in a table. What you can do is draw a picture. So I'm going to show you how that works. So there's our x-axis. And then what we can do is we can say that there's going to be a probability, whatever it might be. So this would be a continuous distribution because at any particular little location, there's a probability of that happening. But there's so many of this, there's an infinite amount, I can only draw it as a curve, continuous curve. It's not going to be a histogram, for example. Okay, so that's an example of a continuous distribution. Notice the probabilities always have to be positive, so you can't go below the x-axis because you can't have negative probability, right? And what we do is we say, let's suppose we have two values. And let's suppose we want a probability between here and here. Then what we do is we draw some vertical line segments, like so. And we can say that the area of this region here will be the probability of it happening. So if we want the probability of something between, let's say, I'll put some numbers in just so we can say it. Let's say this number is 3, and let's say this number is 5, then the probability that we're going to land between 3 and 5 will be the area in between. Does everyone see the pictures? Okay. By the way, what do you think the area of the entire thing is going to be? What do y'all think? If you take the whole area under the whole curve, what are you going to get? Yeah, 1. You have to get 1 because of the 100% chance that it's going to land somewhere, right? So the full area is always 1, and that's important. So the probability from negative infinity to infinity is always 1. We're going to use that. All right, so here's one issue. We don't know in this class how to find area of curves like this. And so who has had calculus? Okay. Actually, it doesn't look like the derivative. What does it look like? Those who had calculus? You knew there was calculus, but it's not the derivative, it's the integral. By the way, just ignore what I just said if you don't have calculus. There's a lot of math behind everything we do. Okay, so for example, in the discrete distribution, we actually did a dot product, even if you didn't even, I just kind of hid all that. But there's a lot of math here. Now, we don't know how to find area of curves like that, except for Sean and Morgan, but it's not a requirement of this class. But there is one area that is a requirement of this class. Okay, there's one particular example where you should know how to find an area of. Any guess? Where you're going to have a curve, kind of, and you're going to be able to find an area. And the hint is it's the simplest kind of area. And what's that? Look into the chat box. Don't see it. What's the easiest area that you can find for a curve? the only one that all of you know. Yeah, rectangle. Rectangle. All right, so let me draw that. So if we have instead, that's supposed to be a straight line, by the way. Not the best artist, by the way. So if instead of some weird shaped curvy curve, if we have a rectangular distribution like this, then we have a name for it. And that's called a uniform distribution. And what that means is that the probability of any interval happening is the same if the base of the interval is the same. That's what uniform means, right? Wearing a uniform means you need to look like everybody else. Isn't that what uniform is? So that's what uniform distribution is. It means that no matter where you're looking, it always looks like a rectangle. And you should all know, I hope, what is the area of a rectangle in general? Length times width. I like to write base times height. Same thing, though. I like BH. L looks too much like a 1, especially with lowercase. But however you want to write it is fine. But length times width is just fine. So we're going to be using that. So you ready to do a problem on it? I'm going to have to erase this. And let me paste in. Oh, you know what? I have an idea. All right, so here's a question. It's actually 3 questions. So suppose the time that students spend in the Math Center is uniformly distributed between 10 and 120 minutes. It probably isn't, but if I say the word suppose, then you got to go with it. Okay, be sure to show your uniform distribution charts. So the first question is, if a randomly selected lab user is observed, find the probability that student will spend between 30 and 70 minutes in the math lab. That's what we're supposed to do. So what we do is we draw a picture. And by the way, it is mandatory you know how to draw this picture. So you're going to have to draw pictures for the exam. It's a very simple picture. It's a rectangle. And you don't have to draw perfect lines because I can't do either. So, but it should look somewhat like a rectangle. And then we know that it's uniformly distributed between 10 and 120. Okay, how do we find the height of this rectangle? In fact, let me label it H. What do you know about the base times the height, or the area of the whole rectangle, given this is probability? And I just realized I got to get my chat on. Come on, chat. There it is. So what is the area of the whole rectangle? The hint is it's very easy. The area of the whole rectangle is 1. Right? When you have a distribution, when you have the whole thing, the area is always 1, right? Okay. And I see a couple of 1200s, and that's not quite right, and we'll look at it. But what we can say is that 1 is equal to the area of the whole rectangle. Another way of finding the area of the rectangle is base times the height. Well, the base is 120 minus 10. That's how you measure something, right? The height is h. So whether you like it or not, we do have to do some algebra. And we need to solve for h. It's not hard algebra, but you definitely have to know how to do it. So first, what's 120 minus 10 is 110. So we can say that 1 is equal to 110 h. So what is h? Yeah, 1 over 110. Any questions on this? One thing you got to remember, this is a math class, so I don't feel guilty that I'm doing a little algebra. It's very basic algebra, but you do need to know a little basic algebra. So I'm going to write h equals 1 over 110 over on the rectangle. Any questions so far? All right, so now we want to find out if you randomly select a student, what's the probability they're going to spend between 30 and 70? So what I'm going to do is I'm going to mark 30 and 70 on the graph. And you don't have to be perfect, you just have to do kind of a representation. So there's the rectangle between 30 and 70. Let's write it out. Any questions so far? So the probability that's between 30 and 70 is the area. So that's going to be the base times the height. Any questions so far? What's the base of this rectangle? Yeah, 40. But I'm going to write it out, 70 minus 30 in case not everyone sees it. And then the height is 1 over 110. And that is equal to 4/11, I guess. Any questions on that? I want to warn you, it's always easy to watch. It's much harder to do. I don't know if you found that, but that's definitely going to be true. Any questions on this example so far? All right, so now I want to find the first quartile for the time that the students spend in the math lab. So let me sketch another rectangle. I think I'll do it in black. That's what I really meant to do. So there's a rectangle. We know that we have a 10. We have a 120. The height, we know, it's still 1 over 120. That doesn't change. Now, who remembers what it means to be the first quartile? What is a first quartile? Again, that happened in chapter 2. Yeah, the 25th percentile. So what that means is the area to the left should be 0.25. So I'm going to draw like so. So that area is 0.25. I don't know this number down at the bottom. And if you don't know a number in math, what do you usually do? Yeah, we call it x. So now, again, there's going to be some algebra. We know that the area is going to be the base times the height. Let's write this down. The base is going to be We don't know. It's x minus 10, though. At least we can write that down. The height is 1 over 1. Actually, it was 1 over 110, wasn't it? I think I wrote it down wrong. Over here, let's kill it. So the height now will be 1 over 110. But we also know the area is 0.25 because it's the first quartile. Anybody lost? Because I am doing algebra. Okay, so now we got to do algebra. We need to solve for x, and you've done that before, right? So to solve for x, what should I do first?
Isolate the variable.
Yeah, so what's the first piece of arithmetic I should do to isolate the variable? Anyone see? Looks like you're all smiling because you love algebra so much.
The 1 divided by 110. Would that be it, or?
Yeah, so let's multiply left and right by 110.
Right.
Okay.
Oh,
So
you'd flip it, right?
Yeah, or just multiply it by you multiply by the denominator.
Yeah.
So we can say x minus 10 is equal to 0.25 times 110. Any questions on that so far? Okay, now you should all know what to do to get x by itself, which is?
Subtract x, or add 10, sorry.
Yeah, add 10 to both sides.
Yeah.
So we're going to have x is equal to 0.25 times 110 plus 10. You're allowed to use your calculators. So you get what? 37.5 or something like that? Is that right?
No, you're doing the smart thing. I'm not.
Your calculator and tell me what you get.
37.5.
Yep, 37.5. I did in my head, but I don't trust myself. I'm one of those weird people that actually enjoys doing arithmetic in my head. Okay, any questions at all on that? So that means the first quartile is 37.5. Any questions so far? Okay, the third question is an algebra instructor will be given extra credit to students in the top 8% based on how long they spend in the math lab. At least how long must a student spend in the math lab to get the extra credit? Any questions on the question? Okay, so let's work this out. Maybe I'll do same thing, but I'm going to do it in green this time. So top 8%, somewhere around there, not drawn perfectly to scale. So what we know here is we know this area. What's this area here?
It's x.
Oh, it doesn't show.
It's actually not x.
Or it's a
1963, maybe.
8%.
Yeah, 0.08. You always want to make decimals and not percents, because the calculator does not like percents, by the way. So you definitely need to use decimals. That's 0.08. And let's not call it x because we call the other one x. Let's call it y. I mean, it wouldn't hurt to call it x, but it could, on the picture, it can be confusing. Okay, and then we do something very similar. We do 120 minus y. Times 1 over 110 is equal to 0.08. Any questions on that? Now some basic algebra. We multiply by 110, and you get 120 minus y is equal to 0.08 times 110. And then what we can do is we can subtract 120 from both sides, and you get negative y is equal to 0.08 times 110 minus 120. And then finally, we got to multiply by -1 to get rid of that negative. And we get y is equal to negative 0.08 times 110 minus 120, plus 120. Any questions so far? Any questions? Okay, and then you stick in your calculator if you want. And let's see, 111. No, that's not right. 88. No, 112, right? Right. 111.8 or something like that. That's 88. 8, 112, 111.2, possibly. So stick in your calculator, tell me what you get. Yeah, 111.2 is what I get in my head. By the way, don't try and do it in your head. Any questions on these questions? Okay, starting to look a little more like math, isn't it? Some of that first chapter didn't look like math at all, and this is starting to look a lot like math, isn't it? So there's a reason why this is called a math class. All right, so I want to do one more question. So I got to kill all this. Okay, so here's what we got. Suppose the number of ounces of water that people drink from the drinking fountain is uniformly distributed between 1 and 8 ounces, and that the number of ounces of water that students use to fill their bottles in the drinking fountain is uniformly distributed between 4 and 16 ounces. You got it? Okay, you'd expect that. People use more water for their bottles than when they're just drinking out of the fountain. At least I do. You watch Thorne take a 2.5 ounce drink out of the drinking fountain, and Preston fill his water bottle with 5 ounces of water before he runs off to class. Whose water usage is more unusually small compared to the rest of the people who use the fountain or the corresponding water usage? So here's the question. Do you remember how to decide how unusual something is? What statistic is going to tell you that? See if you can put in the chat box. And I got to look at that. So what statistic tells you how unusual a value is? Very important for your project, for example. I'll give you a hint. I'm just looking for a one-letter answer. So less than 0.05 is that if it's something is unusual for probability, but there's a one-letter answer that measures how unusual something is. Do you remember? Z. Does that ring a bell? Yeah, the Z-score. The Z-score is a measure of how unusual something is. So we need to find the z-score for both of these particular examples. So before we do that, we need some formulas. Because one is we need the formula for z-score. That one you may remember. And that is, let's write it out, z is equal to x minus mu over sigma. Does that ring a bell? It's supposed to. Okay, so that was the z-score formula. And mu, this is a formula you haven't learned before. Mu is a mean, right? So it's actually kind of obvious what the mean might be for uniform distribution. So it's a rectangle, then it should be right in the middle, right? And the way you find the middle is you add them up, add the left plus the right and divide by 2. Is that clear? So mu is equal to a plus b over 2, where a is the left, b is the right, and 2 is just a number. Because it's the average of the left and the right. Sigma is one of those I'm just going to tell you. It's the square root of b minus a squared over 12. Okay, so first thing to recommend is this is a really good formula to stick on your note sheet for the test. So that if I give you a uniform distribution problem, you certainly don't want to memorize these, do you? Especially the second one. The first one's actually not too hard. That's just the average. But the second one is brutal. And it's easy to use, but hard to memorize. E is really hard to derive. You definitely need a lot of calculus, and I'm not going there. But there's the formulas. Any questions so far? And I want to let you know that the 12 is under the whole square root too. All of this is inside. So let's look at these. Okay, so we got 2 people, right? We got Thorn. Okay, Thorn used to be my student, by the way. These are real people. I think one day I actually saw them using the drinking fountain, and it inspired me to do this question. So we have Thorn. What's Thorn's x? That's supposed to be easy. You just have to read the question. So x is equal to?
2.5.
Yeah, 2.5, because it says he drank 2.5 ounces of water. Then I'm going to need a pencil for the next one.
I need to drop.
So what's the mean for Thorn? Now notice that Thorn, okay, Thorn is using the regular drinking fountain, okay, and it tells you, okay, so it tells you that for the regular drinking fountain, it's uniformly between 1 and 8.
Right.
So it's 1 plus 8 over 2.
Yeah.
And that's 4.5?
We have horizons, so
Any questions on the mean for Thorn?
let me
Thorn's standard deviation is equal to the square root of, I'm going to do some of this in my head, b minus a is 8 minus 1. That's 7.
let me log
You know, hopefully everyone's okay with 8 minus 1 without me showing work. Squared over 12. What I'm not going to do is that in my head, because that's really hard. Any questions on that? It's a little more than 2, but let's see if you can put that in your calculator and tell me what it is.
Yeah.
I'm worried. I did it in my head, and I didn't.
Sorry. Yeah, that's wrong.
I think you forgot to take the square root, maybe.
I did.
0.021. That sounds right. I know it's a little more than 2 because I know 49 over 12 is close to 48 over 12, which is close to 4. Square root of 4 is 2. That's what I did in my head, if you're wondering. 2.021. Okay, etc. There's more decimals, but that's good 3 decimals. So we do the z-score. Let's see if you can get the z-score. One thing to remember when you're doing the z-score, you got parentheses around the x minus mu, or the calculator will do it wrong. So let's see if you can tell me what the z-score is. Remember, it's x minus mu over sigma. And I can do it in my head. See what you get. I get around -1. Not exactly. You can do it in your calculator a lot better than I can in my head. -0.9897. That sounds really good. That's close to -1. Actually, I could have just used my letters on this one. Let's do that. So z is equal to -0.9897, around -1. Let's do Preston. First thing, X for Preston is 5. 5 ounces of water. And now let's get the mean and the standard deviation. So the mean is equal to, so again, A plus B over 2, but now we're talking about the water bottle fountain, and that is between 1 and, I'm sorry, between, where is it? People take the runners, 1 and 8, and the number of waters fill the bottle is between 4 and 16. So 4 plus 16. I can do that in my head easily. Divided by 2. I bet you can all do that in your head, right? 4 plus 16 over 2. 10. Good. And then the standard deviation, that one's going to be much harder to do in the head. That's going to be a square root. And again, I'm going to, actually, this is not too bad. So notice you're going to have 16 minus 4, which is 12. Squared over 12. Which is around 3.5-ish, something like that. Does that help me out? So what do you get when you put that in the calculator? I like to let you do it because it's good practice for you. I could do it in my head well enough to be able to figure out if you got it right. But I can't do it well enough to get like a bunch of decimals. 3.46, so not too bad. I was pretty close. .46. So now look at the z-score. Let's see if you can plug it in. So again, z is x minus mu over sigma. or 5 minus 10 all over 3.46. .3-ish or something like that. 1.4-ish, negative 1.4-ish. Off by a decimal place. All right, so who was more unusual?
And I didn't go because
Who was more unusual? Take a look. So do you remember what the z-score tells you? Okay, if you're farther from 0, you're more unusual, right? Preston, good. Good. Preston's farther from 0, right? Right? They're both on the left-hand side of 0. Preston is farther on the left, right? 1.4 on the left. Thorne is about 1 on the left. So Preston Preston's usage was more unusual. Any questions on this? Okay, so notice I've given you 4 kinds of questions today. We did the expected values and standard deviation question. We did a binomial. We did a uniform calculating by areas, and also a uniform of z-scores. That's pretty much the 4 kinds of questions for these 2 chapters. So we need a secret word. And here comes the big secret word of the day. I'll do it in purple. Secret word is rectangle. Because if you're doing a uniform distribution and you want to find area, you got to draw a rectangle. Any questions? So as always, I'm done in terms of everything I need to say for going over some problems. Again, you want to watch the long video, read the chapter, but you don't have to read every section of the chapter. Just the stuff on continuous distributions and uniform, and the stuff on binomial and discrete expected value stuff. So if it looks like something I've never talked about, you don't have to worry about it. So at least for a moment, I'm going to unmute you all, because this is the time for you to ask questions.
slightly torturous.
Although sometimes we end up with all kinds of interesting things when I unmute. Some of you won't let me unmute you, and that's okay. So if you have questions, this is a perfect time. Just note, this is time to think about your projects. These chapters are not that difficult. I think you'll find them. There's 4 standard questions, basically, and hopefully you won't find them too bad. But there's stuff to do. But you can definitely start working on your projects. Just a note, I've noticed on some of the discussion forum stuff, if given a choice, you're much better with a survey question where the answers are going to be more varied. So it's much better to ask how many times a month something happens than how many times a week something happens. Because how many days a week is never going to be more than 7, typically, right? But how many days a month, you'll get a larger amount of different answers. So that's just something I've noticed a couple questions about. I figured I'd remind y'all. So again, as always, I will stay online until there's no questions. And if you have none and you want to say goodnight, that's okay. If you have questions, that's even better. You can ask.
Can you walk me through getting the z-score really quick?
You mean just the last bit?
Yeah, just
Okay.
the last bit. Can you just put in values for how you got it all?
Sure.
Thank you. Thank you.
So it's a fraction because z-squared has a formula. And it's x minus b over sigma. So let's do it this way. So for this first one, the x was 5 minus the mean was 10. Or this is the second one, sorry, this is Preston. And sigma is 3.46.
Okay, yeah, I put it, yeah, and I messed up for where it's supposed to be. I get that.
And I want to remind you, you need to put the parentheses in your calculator. If you don't use the parentheses, it'll give it the wrong answer for you. So if you just do 5 minus 10 divided by 3.46, it's wrong.
Thank you.
Parentheses 5 minus 10 parentheses divided by 3.46.
That was where my issue was.
Yeah, it's a common issue. That's why I'm saying it a few times.
Thank you.
Okay, great. I'm glad you asked. Other questions? I'm also looking at the chat box just in case.
I actually had a question, but it was in the textbook.
Uh-huh.
So I don't know if you have the book open. It
So
was
you want
on
to get the
page.
textbook? You want to look at the textbook with me?
Yeah,
Okay.
it was on page 241.
I think I only have the online textbook and not the PDF textbook. So we may have to go by, let's find it. I don't think it has page numbers, in other words, because it's online. But we'll get there anyway. I have to redo a share. And let's go find it. That one. Okay, do you remember what chapter?
Yeah, 4.1.
Okay, 4.1. And tell me when to stop. How's that? I'll go slow so you can.
I think you might have passed it. It was kind of like at the beginning.
I'll go back to the beginning.
Yeah, it was like the first example.
This one right here?
Yeah. How? So my question is, when they're calculating with a sample of 50 mothers, how did they get the numerator of the probabilities? Like, how did they get 2 over 50?
Okay, so let's look at it. A child psychologist is interested in the number of times a newborn baby's crying wakes a mother after midnight. A random sample of 50 mothers of following information was obtained. Oh, I think they just gave it to you.
Oh, they just gave it to us?
Yeah, I can understand your question. Yeah, because they didn't tell you how they got it. They got it by doing a sample of psychology thing.
Oh, okay. Because I was really confused on that. I'm like, how did they?
Sorry about that. Yeah, they just gave you the numbers.
Okay.
In my example, I showed you how to get the numbers. But I gave you 2. I gave you like 12% and number and 8%. So they'll be given. Sometimes they'll be given in the table. Sometimes they'll be given in a sentence. But one way or another, they're given.
Okay. Thank you.
Okay. Other questions? Good question, though. I can see why it could be confusing. Other questions? So Stephanie, Claudia, Linda, Sean? Any questions? Stephanie and, no, Sean and Linda? Okay, good night, Sean. And Linda, you're the last one, I think. I can't hear you. I think your volume's not high enough. Still can't hear you. You could type it in the chat box if we can't hear you. So sorry about that, but I think your microphone volume might be too light on your computer. How do you change the username to Linda? That's a good question because I know it always says user 1. If you give me about 10 seconds, I can go and play around and see. And in fact, I wonder if I can share to that. Let's try this. Not sure if it'll let me. Let's try this. Okay. So I think you get, do you have this? You can go like that, or you can type either way. Because I can't hear you, remember. So it should be in here. I've never done this before, but probably under settings. Let's see. This is it. General. Probably when you first did it, you didn't type in your name, so it just gave user one. So it's a good question. Nowhere in here, it doesn't say here. Shouldn't be under contacts. Ah, got it. Says Linda now. Okay, whatever it is, it worked. Okay, other questions? Okay, well then I'll say goodnight, and say goodnight to all of you who are watching this as an archived video. And please post on the Q&A forum if you have any questions about stuff from chapter 4 or 5, or post on the project discussion forum if you have questions about the project. When you're ready and you have your project written, send me an email with your full written project. You can only do that once, though, just a note. And I'll be happy to read it and give you lots of feedback. So until then, have a good evening. I'll be checking the forums all week, and I'm always happy to answer your questions. So good night.